Hey guys, this is lesson 21, day 2. Day 2. And it's a continuation of the conversation around domain of a function in context. And just a little reminder, let's talk about how you can identify the domain when the function has been graphed. And so, intro task, I forget what page it is, but the point is, lesson 21, day 2. And so, when we're talking domain is all possible x values. So for this question, an x value, the location of this ordered pair is 1, 5, and its x value is 1. This ordered pair has the location 3, 5, and its x value, again, domain is the x, or all possible x's. So 3, this one is at 4, and if we put little braces around the group, you have formally defined the domain. Wait, I forgot 6. So I guess I'm just going to rewrite it. 3, 4, 6. Now with curly braces. I mean, I don't want to mistake that each of those count, whatever those notation things are. Okay, so then a couple of the ways that we can write the domain of something is to think about, do we have the information that we need? Where'd you go? There you are. Do we have the information that we need from intervals, rates of change? And so in our case right here, if I look at this half circle, the half circle starts at -5 in the x direction and goes up to +5. So I could write the domain with interval notation like this. -5. I think it's equal to, I think you can actually be at -5, thinking about my circle formulas. And it's definitely an x, so there's my x in the domain, and 5. Yeah, that would do it. That would be my interval, my inequality notation to describe the domain. Let me use a different set of notation. And so in this one, I want to use the parentheses and the brackets. So I see that there's an open circle, so I'm going to put a parenthesis for the start of this interval of all possible x's between the two numbers. And it goes up to 5, and because the 5 is filled in, that gets to be a square bracket. Okay, we have 2 words. And I mentioned these in the previous video from lesson 21, day 1. It was on the idea that the number of canvas prints cannot be a fraction. If you say that the number of canvas prints cannot be a fraction, then that means you have a discrete situation. So we have something like a series of points, and there's no continuous line between them, versus continuous. Let's say it's the amount of gas that you're using while you're driving on a road trip. And so, you don't just dump a gallon of gas in your car and it burns up and the car drives for 70 miles, and then dump another gallon of gas and it burns up and then you drive for again. The car is constantly making the amount of gas disappear, a continuous rate. I mean, I'll leave that as it is. So in order to do that, a continuous situation uses a straight line. Formal definitions, I mean, first of all, I'm going to put, ask Google for like the full clarity of them. But I just want you to know that the definition, the my verb, my language, is any situation where you need distinguishable points. All right, so any situation where you have to know that point is different from that point, and they're different from that, and they're different, and they're different. So you can clearly tell that there is a gap between the points. In a continuous, it's any situation. So that could be like with context, like the gallons of gas being used up. It could be without context, just like, hey, look at that line. All right, any situation where the points have a neighbor really close. So I should say where all points. So maybe I'm like adding an element of my own like storytelling from what I know in the world of mathematics to what the situation means. You call it a neighborhood. We call about, you can make your neighborhood super small. There's always at least 2 points in the neighborhood. And that means like you can make them infinitely small, and there's still always 2 points in the neighborhood. But that's a formal definition that I don't need to go into anymore. But I want you to know it looks like that. You have a straight line. You never have to pick the pencil up. That's another way to tell if you have continuous. The pencil goes on the paper, you draw your line, and then after you're done drawing it, continuous. The function y equals 15.95x represents the cost in dollars of X tickets for the South Florida Museum. Wonder what that's all about. Is the domain of this problem discrete or continuous? It is tickets, right? Dollars. That's usually always the dependent variable. And because dollars is dependent, right, that means that the other thing. So time is usually independent, dollars is usually dependent. So this means tickets is independent. And that kind of makes sense. If you don't buy any tickets, then the amount of money you spend depends on you not buying a ticket. You buy 1 million tickets, and first of all, you're a benefactor. And then that also means that you're going to spend a lot of money because the amount of money depends on the number of tickets you buy. So the domain is related to tickets, and tickets are, you can't buy a fraction of one. It's discrete. The first ticket you buy is separate from the second ticket you buy. And so because they are definitely different, that means that the number of tickets can't, my writing's amazing, be a fraction. Yes, I know. You can't have a part of one. Should the domain be the set of all integers or all real numbers? I say no to both of those. No to both. It should actually be the set of all positive integers or all non-zero positive integers. So it's actually, I mean, you can't have a negative ticket. That's why I'm saying no to both. It's not all real numbers because you can't have fractions. And it's not all integers because negatives, what's a negative ticket? They're going to pay you to not go there? I would take that deal. All right, actually, it's all positive integers. Okay, I got time for one more before I'm just going to end the video. This will be part A and I'll load part B later. What's the domain of this function? I mean, it just kind of addressed it right there. Let's say that it's all x such that x is an element of the set of all positive integers. Whoa, I shouldn't show that to you. That's beyond you right now. That's if you want to be a math major, a computer science major, whatever in college. Let's say it's this, boom, answer the question. Okay, I'll continue example 3 in the next question, and that's it for today. Well, for now, like and subscribe.